United States Department of Agriculture.
Okay, so we're going to start with, so a little bit of background. We've got 4 data teams that we've worked with throughout this ARDN NEPA-funded project. And we're going to hear from each one of those teams, the PIs of each one of those teams, to just tell a little bit about the data that they prepared, a little bit about the process of what they went through, and just their experience with being an ARDN guinea pig. So we're going to start with Lori Abendroth, who is formerly with Iowa State University, and she's now a research agronomist at USDA ARS.
Yeah, great. Thanks, Cheryl. So yeah, the data that I'm going to be presenting on is sustainable corn data, it's called. So as Cheryl mentioned, we were a test case and one large data set across 30 experiments in the Midwest for 5 years that then would be a good evaluation of the tools, the Dmapper tools in particular, and how those align with our data. So the team was funded by USDA NIFA from 2011 to 2016. At the time, we were the largest corn research team ever funded by USDA NIFA at 20 million. And really the intention was to be transdisciplinary in nature. So we had goals of sustainability indicators, environmental footprints, and climate adaptation for corn-based systems in the Midwest. The team was 140 active members at any one time, 250 members total across those 5 years. And so just trying to coordinate and align and make sure there were no bottlenecks in the team that size were critical, but really provided robust data, biophysical and social economic data. So the data I'll be presenting is only the biophysical that we aligned with the Dmapper and Icosa dictionary. So our field research network had 30 experiments across all of these Midwest states. The experiments are the orange points. So an important thing with this is when we were funded, as many teams I feel like are funded by grants, when you bring experiments in, you're using existing field research experiments that may or may not have the same treatment alignments as others in other states. So we had different experimental designs, different treatments. We had always at least 2 sites that had the same treatments. But this is something where we had to align as a team in our dictionary and making sure that we were talking the same language and really being transparent in what data was being collected, what treatments were being studied. So you can see here, it was a lot of cropping system efforts, organic, conventional crop rotations, cover crops, drainage, water management, nitrogen, fertilizer, tillage, and landscape position. So data were critical to our team, and I think every team, kind of large data sets, have this type of flow chart on the right, where we collect the data, we put the data in, the data is used for models, it informs stakeholders, the stakeholders change the way they're farming based on our project. And the thing that I always emphasize over and over is that data is critical to having this workflow continue and not hit a snag. And so just for our team efforts, the data were critical to have in a transparent, harmonized language across all of our 30 experiments, because otherwise even the modelers, crop modelers, water biophysical modelers would hit snags if they couldn't ingest those 30 experiments. So as I've said before, data management can never be done just for data's sake. It has to drive research goals, and people are going to be passionate about it. And so that was where our team aligned as well. And we were not actually required to share our data post-funding. Now USDA NIFA grants have this language that the data should be shared post-funding. We felt that as being the largest funded corn team, that if we were going to model and build capacity for open data and agricultural science, that we wanted to do that. So we worked quite hard to enable the usability of the data in the project life as well as post-project, which is where this ARDN team then continued to build on that and allow us to build capacity beyond what we were originally funded for. So throughout the time of our 5 years, we had a number of conversations with AgMIT, as Cheryl's noted, because we had a couple AgMIT modelers as part of the team. And then we also had conversations with National Ag Library and NIFA as to understand their goals, their systems and synergies of how to align with it. So what did our data look like? One thing I'll note is that we only had 3 part-time personnel that were actually funded for the sustainable corn cap data. So I think it's always possible to align with these harmonized dictionaries and so forth, especially if you do it from the beginning. It's always harder to work retroactively. So I always encourage that as much as possible in getting it set up in a standardized format. Another thing that was really important, and I thought relevant for higher usability by modelers, is if we publish all 30 sites together. So versus each 30 site publishing their own files as a CSV or Excel, we publish them together. And what that looks like, for example, is here on our soil data. You can see under the unique ID, the first column there, we have CPAC as one site and SURF as the next site. And so as we go from left to right, you can see depths varies and the years sampled, and then they're populating in whatever variables they had reported for those years. But that way, when a modeler comes in, they can simply query and get all bulk density variables that exist across all sites versus having to go to 30 different files and download, which is how sometimes large project teams have done it in the past. So this format did help us then more easily transform to the ARDN structure as well, because we already as a team had centralized, standardized, quality controlled, and had them all in one file to enable that translation of our variables a bit easier. And so then one thing we did is we had created our own dictionary. So as Cheryl had mentioned, when you have big projects, they often then create their own dictionary, which is just creating extra confusion posts. We did that partly because we had examined the dictionaries that we knew existed at the time and couldn't find any that utilized everything or the variables that we were measuring. So we did create our own, and this is what's published under the original data set, but that dictionary has now all been transformed to the Icosa dictionary. So we originally published the sustainable corn cap data at Ag Data Commons in 2017. So you can go there today and find that. And this includes all 30 sites, all data. But then that one's at top and referred to what I call as the parent data. So that's kind of the original publication. And then the child data, or the break off from that parent, is the ARDN data. So now it's the exact same data, except it's all been restructured and harmonized to align with the Icosa dictionary and the format that's needed to be able to read it in easily into Icosa, which I'll show in a second. So originally under the parent data set, that original publication in 2017, we had 2 files, the data dictionary here, and then we published it originally as an Excel file with multiple tabs. We did that at the time because of concern, like people may only download 1 or 2 files and then not understand how they related to the others. But obviously that's not quite as good for machine readability. Now when we go to the ARDN version of the data, there's 14 files, and each are CSV and really broken up into the major types of data that they're reporting. So you see here like site metadata, that's site history, descriptions, plot identifiers, weather, agronomic, soil, and so forth. So what did we have to do to align it with the Icosa dictionary? First, we had to restructure plot IDs, treatments, and measurements. That wasn't a huge thing, but just necessary to make sure it was clear and that it would align with variables to the Icosa dictionary. So I think this is really important when we think as a global agricultural community of implementing this Icosa dictionary. It is a flexible, open source. So as I was going through my data, for example, there wasn't a lot for water quality or water quantity metrics, so from drainage, subsurface tile drainage systems. And so we just added those into the dictionary to be able to ingest more of my data. So this is something when you look at your data sets or others, what can we add to the Icosa dictionary to build capacity? I think we added maybe 30 or 40 variables in total. So I use the Dmapper to translate my original codes, those original data dictionary codes from the Sustainable Corn Dictionary to the Icosa dictionary for 14 CSVs, which I showed you the screenshot just previously. These are some of them. And then on the final point below, I wanted to make sure to mention I did not translate pesticide operations, insect populations, or soil moisture data. So this is one thing, because it didn't exist in the Dmapper or in the Icosa dictionary very much for like herbicide applications, insect populations, I didn't translate those. And because I felt that the crop modelers, the models that they used did not have capacity to really utilize those data anyway. So then it's kind of thinking of the core data, what are crop modelers most interested in, translating those and not necessarily concerned about the other variables that I don't think they were going to use anyway. So this is the Icosa dictionary. This is a Google link that's linked from our ARDN webpage and so forth. But you can see here that, yeah, there's a lot of data types, a lot of variables. And so it can be overwhelming if you're just looking at a Google spreadsheet like this, trying to figure out which of my codes would align with these codes. But that's where the Dmapper really came in helpful. And I'll show that here in a second. So one thing when I mentioned translating the operations, this is how the original parent data looked. So you notice how we originally structured it. We have the site ID or unique ID on the left-hand side. So for example, this is Arlington up in Wisconsin. And then we had operations all in one column. So synthetic fertilizer applications or planting corn, soybean. The Dmapper tool is really set up to better ingest it if you have all planting operations as a standalone file or all fertilizer applications. So that's what now the new data set looks like this in ARDN, where now we have, again, unique ID on the left-hand side, this is SURF, and then only planting operations. So you can see a few columns over, we have operation and all of them are plant corn and so forth. Another thing we realized is that we were assuming people would spend the time to understand the data or be able to piece together operations. I'll go back here a second. So like here, you don't see any plot numbers. So what the user would have to do is go in and align the planting corn date with all the corn plots. And that is pretty time consuming for a modeler to figure out which plots that is and so forth. So then in our ARDN data set, we actually reproduced every operation for each plot ID there in the fourth column that it was applicable for. So that way a modeler could just ingest it on the plot level. And that aligns also with the biophysical data that's reported. And then here's the Dmapper tool that I use a lot for my 14 CSVs that I was translating. And you can see across the top, the green columns are the translating it from the Sustainable Corn Cap Dictionary to the Icosa Dictionary. The ones that are green are directly translated. The ones that are gray are columns that I decided weren't really necessary to translate or weren't critical for crop modelers or were repeated in another place. So the sidecar 2 file, that JSON file that pairs with this, notes that as well, or it just kind of ignores those columns when the crop modelers would be taking this and ingesting it or translating it with their model. So for example, this is on one of the columns, crop year. You can see up here where it says raw data header. In my original dictionary, I called it crop year. The Icosa variable below uses experiment underscore year. And so all I had to do was put year in, and then it started pulling up similar Icosa variables that were relevant to years. So I could select that and then hit save. Another example here was one that I actually customized. So this was not in the Icosa dictionary, but I added it in plant maturity or hybrid maturity. So originally I called that plant maturity. I renamed it to the variable code of Matt _group, just to kind of align better with the Icosa structure of codes. So that was done across all of the operations and biophysical data, and it is now hosted here on the ARDN page, and you can see it's, I think, the first one in the list of our available data sets for use and download. So, any questions?
Thanks, Lori. Let me check and see if there's questions online. So anybody have a question for Lori about the CornCap data?
I mean, I just have a comment that I appreciate the openness of the data being in CSV. She could have just as easily put it in one Excel file after she aligned it and put it in there, but it's actually a more open data format in CSV.
Yeah, that's true. It's not proprietary.
Right, and it's plain text, so anyone can actually read it.
Yeah,
I have a question. So based on you doing this process, do you have suggestions for data collectors for how they, like, if you were to do this again, for example, is there anything that stands out as a way that you would do it a little differently next time?
Yeah, great question. So what would do differently next time? I think first would be aligning with the Icosa right up front, and then keeping some of like the operations in particular separate files. So so yeah, having all planting and so forth as standalone from harvest and fertilizer applications. That definitely aligns better with the Icosa. And then there were a few things like how agronomic people collect data. We always like one row going across for each plot, which is recommended, but then sometimes like we would put the header was maybe like corn plant population was one column, the second column was like soybean plant population, but that gets hard because in Icosa is just plant population, and so then you have to add a separate column that defines crop, and so it's kind of better than if you just have the overall variable that you're collecting, but not defined by crop in the header. If that makes sense. So yeah, thinking there's some of those things up front that would reduce the amount of reconfiguration down the road.
All right, thanks a lot, Lori.
Yeah,
That was
thank you.
wonderful. Okay, so next up is Brian Baer from Michigan State University.
USDA is an equal opportunity provider, employer, and lender.